Assume the cantilever of the previous example, length was 14 feet. This time, it's 21 feet long. And it says determine the approximate depth needed when the moment, if other conditions remain the same. Okay, so it says remain the same. Live load is 2.5 kips per foot. And then dead load is 1.2 kips per foot. F prime C still is 60,000 pounds per square inch or 60 KSI. And RB is equal to 16 inches. Sandali. Parang merong mali dito. 60 KSI pa yung F prime C. Okay, I will check this. Anyway, if we're going to compute for the self weight, we'll get 0.8 per foot. Okay. So upon computing for WU, okay, changing the self weight to 0.8, we get 1.4 times 1.2 times plus 0.8, and then plus 1.7 times 2.5. You get WU equal to 7.1 kips per foot. Now the new design moment will be MU equal to 7.1 times 21, which is our length, squared all over 2. So your MU now will be 1,570 kip foot. This will be the ultimate moment. Now, if we use the graph, okay, so again, RB is 16 inches, okay. Ultimate moment is 1,570, so that's around here, 1,570, so it's here, so your depth would be around 38, not 38 or 39. Now, so, appropriate required depth of 42. Paano siya naging 42? 16 inches, 570. Sorry. Ito palang line na to. No? It's in this intersection. In here. So, 42. There. Kasi 1.5 is here. 1.57. Somewhere here. 16. Okay, you can also use the formula if you wish. So it's 42. Then this is consistent with our estimate. So 48 dito, that's an estimate. Since it is consistent, no, a second trial will not be necessary or will be unnecessary. It is likely that 2 rows of reinforcing will be required. When you say 2 rows, so that it will be accommodated by the width, no? Kasi kapag 1 row lang siya, baka hindi mag-kasya. Because it has to have a cover on the right side, left side, and then at the bottom. Okay, so by the way, if this is a cantilevered beam, where will be your reinforcing be placed? On the upper part or the lower part? Upper side of the neutral axis or the lower side of the neutral axis? Anyone? Yes, Mr. Arreglado. Upper side or lower side? If it's a cantilevered beam, saan dapat yung reinforcement? Okay, if I may rephrase my question, where is the section where it is in tension? Meron na siya. Upper, that's correct. It should be upper. So that's correct, Miss Reina. Thank you for your answer. Kasi the upper side of the neutral axis is subjected to a tension force. No? So it will be the tension stress is there. No? So that's where you place your tension reinforcements. Okay. Any question? So I think the part where you have to assume the depth, that may be a little vague. No? You will ask, Sir Pan, ano ba yung pinakamagandang ano dyan? Way of having a test dimension. Parang first trial, 48 inches, match already. So, ano po ba? Yeah, so you have to be familiar with the usual depths of beams. For example, in this case, ilang inches ba? If it's cantilevered, what's the usual depth? Na given yung strength ng steel and strength of concrete. Okay, any question? May tanong kayo? Wala?
Sir, question po.
Yes.
Sir, bakit po dito pag sa cantilevered beam, pag kinocompute po natin yung ultimate na load, magkasama lang yung dead and live load. Pero compared dun sa ginawa natin last time, kapag yung at mid-span naman, parang naka-separate yung computation natin for dead load and live load. As compared to this, parang W lang siya, then magkasama lahat.
Okay, that's a good question. Okay. You mean itong because this is the service load, that's 1.2, and then this is the self weight. So these are both dead load. That's why these two are multiplied by 1.4. They are both dead loads. Okay. Now, ito naman 1.7, this is multiplied to the live load 2.5. 2.5 live load. Yung subscript dito, that's LL. Then DL, that pertains to dead load. Okay, you might be referring to the previous examples where it was mentioned there, for example, it's purely live load and then neglect dead load. That is why the WL squared over 8 is multiplied by, let's say, if it says it's only dead load, 1.4 lang from MU. Pero yung W niya, it wasn't multiplied by 1.4 or 1.7 yet. Okay? That 1.4 and 1.7, it is also okay if your computation for MU wasn't computed yet with 1.4 or 1.7. Kasi practically, you should get the same answer. But make sure that you only multiply 1.4 for dead loads. Even after this formula is computed. You can multiply 1.4 in here if your WU wasn't multiplied yet by 1.4. I mean your distributed load. Because you usually put one WU if the value is already if the service node was already multiplied by the factor. Okay? Same as in moment, no? When you compute for your moment, and the W that you used wasn't computed by the factor yet. You don't equate you don't use U in here yet. Yung ultimate U pertains to ultimate. That means it was already multiplied by the factor of safety, which is 1.4 for dead load, 1.7 for live load. But be cautious that you don't multiply twice. If you have already multiplied it by 1.4 when you were computing for the distributed load, then you should not multiply it in here already, no? Because that 1.4 is already multiplied. Okay? Did I answer your question?
Okay, sir. Yes, sir. Thank you
Okay.
po.
That's good. Any other question? Other question? Yes?
Ano yung dun po sa effective depth tsaka yung actual height po ng beam? Ano po usually yung mas malaki?
Well, you call it total height. Total. So the total height should always be bigger or larger. Kasi nga effective depth minus the cover plus the diameter of the reinforcements. Okay? From the from yung kasing pag-compute yun ng effective depth. Okay, that's the taken from the outermost compression surface, okay, outermost to the center line of your tension reinforcements. Okay, so you account for the cover, which is approximately 1.5 inches, and then from the surface of the outer reinforcement, outer surface of the reinforcement up to the center line of the reinforcement. Did you get that? Okay, I might have a drawing here.
Oh, sorry na. Ano kasi galit sa'yo?
Any other question? Okay, let me show this.
Kasi ako galit sa'yo eh.
Okay, paano ko ba i-mute kayo lahat? Pero lumalabas lang. How do I? Kindly mute your, ayan, nakamute na kayo. Okay. So that I can better answer your question. Here, okay. Do you see the screen? Okay, this is the total height, which is 38 inches. And then effective depth is 33 inches. Sorry, 38 inches, 33 inches. So the effective depth was computed or was measured from the outermost compression surface, which is from the bottom, up to the center line of the reinforcements. Okay? Do you see that? Now, I am talking about the cover to be this length. Ito yung cover, which is around 1.5 inches. Okay? Of course, accounting for the depth, if we only have one row of reinforcements, ito lang yung depth niya. I mean, diameter of the reinforcing bar. So, if you only have one row, up to here, yung pag-measure mo ng depth. But in here, you have two rows. So, two rows, this will be 5 inches. Okay, ito yung 5 inches. Okay? Any question? Other question? Na-gets natin yon? Sige. If you have other question, just unmute your audio. Okay. Wala kayong question? Okay, I will now just give you your exercises so that you may submit that next Thursday. Okay. Right? You might want another example. Let's have another example. Okay. Okay, let's have another example. This is also in the book. This is example 7.4. It says here the maximum moment in the continuous beam in figure 7.1, okay, occurs at the ends and has been estimated to be mu, that's pu L squared over 9 plus WU L squared over 30. Now, take note, we have a special formula in getting our ultimate moment. Okay, ultimate moment, what do we do when we design? We equate that with the resisting moment. Okay, so that we will get the minimum dimension that will satisfy this ultimate moment, or that will be having that strength, no, at the least. Okay. Note that you have here PU and WU. Okay. So yung PU natin and WU that you will plug in here they should be multiplied already by factors. Now, it's mentioned here, it says the service loads are PLL, that's 10 kips, and PDL, that's 12 kips. Now, PLL, 10 kips, dito siya uh, it's is acting at this point, no, or at mid-span. Okay, so this PK uh, is the location, and it is acted on by LL, PLL, 10 kips, and PDL, 12 kips. Okay. Now, it is also acted on by a distributed load, W, okay, kip per foot. Live load, that stands for itong subscript ng LL, no? And WDL, DL means dead load. Okay, so having known this, you know already which one to multiply by 1.4 and which ones to multiply by 1.7. It says, in this case, the dead load includes the beam self-weight. So, sabi, the dead load includes the beam self-weight. Assuming F prime C is 3000 psi and Fy equal to 60 psi, okay, and width of 14 inches. So width is given. Determine the required approximate effective depth. Okay. Now using the graph C1.3, so I've given you the appendix. Kindly look at C1. So your rho, which is equal to 2/3 rho max, okay, that's the rho that will be used, no? This rho. But then we have to account for PU, or the ultimate concentrated load acting at mid-span. Okay, so multiply 1.4 with 12. Okay, take note that 12 already includes, this is the dead weight, dead load, and then this 10, that's the live load. Okay, so effectively your PU would be 33.8. Take note, this should be kips. Okay, and then WU, multiply the dead load with 1.4, multiply 1.7 with 2. 2 is the live load. The 2 here is the dead load. Now, we did not account for the self-weight because it was mentioned there that the given distributed dead load already includes self-weight. Okay, so WU would be 6.2 kips per foot. So take note, we have kips here for our P. W, you have kips per foot. Okay, do you see the difference? Now, this formula is given already. So just plug in the values that you have computed. Okay, so this is PL over 9 and PL squared, WL squared over 13. Okay, note that with the formula, you will be consistent with your units. Okay, so effectively you'll get 832 kip foot. Okay, so ito na ngayon yung MU natin. This is our MU. Okay, applying this formula. Yeah. Now, entering the graph where you already have your depth. Sorry, it's not depth. Your width, which is 14 inches. So, going to that graph, you will get an effective depth of 37.5 inches. The overall depth will, of course, be larger due to the placement pattern of the steel, stirrups, and the required 1.5 inch cover. So yung cover niyan, that's concrete, 1.5 inch. Now, why do we require cover? Bakit dapat may cover yan? Para wala kang makitang steel. No? Because if the steel is exposed, is not covered by concrete, that will rust. No? Mangangalawang yon. And it will deteriorate, of course, if it, pag nangalawang. Yeah? Did you get the solution for that? Any question? Question? Malinaw? Is it clear? Okay. Isa lang yung nag-thumbs up. If it is clear, give me a thumbs up sign. Yeah. Yeah. Pag wala kayong thumbs up sign, that means you're thinking of something that you want to ask me. Okay. No question? Mr. Arreglado or Mr. Pangilinan? Do you have any questions? What part? Please feel free to ask me, let's say, to repeat a certain portion of the lecture if you wish. Or you can message me if you want to meet me separately. Is that okay? Sige. Next meeting, we will discuss about doubly reinforced beams. So kindly excuse me for 1 minute. Okay, I will now assign you your kindly compute for 7.3 and 7.4. Okay. Sample problem 7.3. Okay, so you have 4 numbers for your seat works. Class. Just work on this. Okay, kindly go through the problems. If you have questions, you can ask me now. Okay, so 7.3 and 7.4, 6.4 and 6.7. Those can be found in the PDF files, no, of chapter 6 and chapter 7. Okay? Now, what you do, you just write your solutions on yellow sheets, no? And then take a photo using your cell phone or a scanner, and then convert that to PDF file, one PDF file, and then just submit it to my email. Okay, now let's agree on the deadline. Okay, when do you want the deadline of submission for this? So this is just it work. As I mentioned earlier in the previous meetings pa, the sit works are very important. I think I told you I put 40% of your grade on sit works. So this is the chance na mataas ang makuha nyo sa sit works. So when do you want a deadline for this? If it's 1 week from now, it will be next meeting. No? By the way, yung Thursdays hindi na tayo nag-meet because you have readings, no? Yung binigay ko sa inyong mga earlier PDFs pa. So our next meeting would be on the 19th. Would you want to be on the 19th or on the 21st? 21st or 19th? Siguro 19th at ayan, inanahan na ako. 21st na lang daw. So, okay na yung 21st. Ayan, sige. 21st na lang. Sige. Oh, there. So, all of you wants to be on. So, 21st, what time? 12 noon? Let's make it 12 noon. Okay? Sige. Kindly refrain from submitting beyond yung binigay natin time. Na? Okay, now, I mentioned on the first meeting that we will be a little bit, not a little bit, but we will really be compassionate for those who are having issues. Let's say for those taking care of somebody who has COVID, ganyan, or kayo mismo mayroong COVID, you just tell me, no? Kasi it might be affecting, or it will affect your performance. So I can give consideration, no? So let's say I'll give you a chance to submit later, ganyan. Okay, so as long as you have a valid reason, no? Let's say COVID related or any personal issues, please don't hesitate to call my attention. Kasi talagang mahirap ang situation ngayon. No? So, halimbawa, you have a problem of, allotting time because you're grieving. For example, nawalan ka ng loved one. Just call me. Call my attention. No? Okay? Tapos, you're affected about what's going on in our country. Political, sabihin nyo lang sa akin. Yun mo, nade-depress po ako kasi ganito, ganyan. But, meron din RAF, yung mental health committee namin. So, soon, magpo-post kami nung kit about, keeping yourself or taking care of yourselves your wellness, physical, mental, emotional. Magpo-post kami sa website natin, yung UPCA website. So keep posted. We are really addressing yung mga problems ngayon. We want to address the problems or issues ninyo, and even the faculty. Hindi lang naman kayo rin ang affected. So tulong-tulong lang. So para sa atin, kung may problem kayo, as I've said, you just tell me. Okay? At kung ano may tulong ko sa inyo, for example, sa project ninyo, structural conceptualization, I'm willing to help you. We just schedule sessions, no? Kung meet tayo. Anyway, I have a free account of Zoom. Okay? Dali, baka makalimutan ko yun. So 7.3, 7.4. Or anything you want to discuss pa, matters sa natin, sa class natin. Yung grouping, wala pang nag-submit pa. No? I only have 2 groups pa. So I'm still waiting for the other groups. Kindly post them. I will be posting the topics na this week para ma-start nyo na rin yung research ninyo. Okay? Wala nang question? For the things that we discussed today, wala na kayong question? Okay, next meeting, we will discuss doubly reinforced beams. So when you say doubly reinforced, you have reinforcement at the tension side, and at the compression side, you also have reinforcement. Okay? So with those 2 reinforcements on the compression and tension side, the requirement for a deeper beam is reduced. No? So of course, architecturally, this is usually preferable because you save space. No? You have greater space or free space because your beam is not too deep. Okay, so that's for doubly reinforced beams. I will post the links. Merong link na video. So you watch that video, and then we also have a set of PowerPoint slides. And we will discuss that next meeting. Okay? Okay, class? So are we do you think okay lang yung pacing natin or very slow? So your thumbs up means okay lang yung pacing natin. Kasi I don't want to be too fast so that you're able to digest what we are discussing. Yeah? Okay, very good. Sige, maraming nag-thumbs up sa akin. Sige. So, if you have no more questions, you can start working on your seat work and continue reading. Mga hindi nyo pa nababasa. You communicate with your classmates, grouping ninyo. And I'll see you next Tuesday on the 19th. Okay? Sige. Okay, bye-bye na. I'll let you go. Bye-bye.
Bye,
Thank
sir.
you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you po.